Okay, so we're going to walk through a rather tricky volume of revolution. So, to be fair, questions 1, 2, and 3 came from past papers, but question 4 onwards came from some university content that I found online from the US. And henceforth, I would suggest that these would be organized a bit differently, presented a bit differently in the event that they were included on an HSC paper. For instance, question 4, which we're going to walk through now, I would suggest that perhaps the graph might be given. Well, you should certainly know how to graph y equals the cube root of x. Considering that this says that we only want to look at the first quadrant, don't muddy the waters, and graph it anywhere but the first quadrant. But considering it goes down that way, and then the first quadrant looks something like that. Basically, it's the inverse function of x cubed. So henceforth, you should actually know how to graph this without being given this graph. But I would suggest that this would probably be graphed for you in an HSC paper. And really, that's y equals the gradient being 1/4 times x, so it's a line going through 0, 0. This is where I would possibly plot some points so that you can determine that this line is actually going to be underneath your cube root of x. And I would guess that not only would perhaps this graph be given to you, and of course that goes down into the third quadrant, I would suggest that part I might say, and hence find the points of intersection that fall within the first quadrant, and or in this case, you know that one point of intersection is at 0, 0. And so I would suggest that that would be a part II where it was asked that you find the point of intersection. So therefore, that's point of intersection, not point of inflection. So just solve it simultaneously. Set the cube root of x equal to your line. So 1/4 x. I prefer that rather than x on 4. And cube both sides. So we got x equals 1/4 cubed, x cubed. Just going to make it simple because I know what I'm going to do in the end when I go to factor this. I don't want to calculate 1/4 to the third. So I don't particularly want to be working with a fraction either. So I'm going to multiply both sides by 4 to the third, so that I get something a bit easy to work with. In this case, I'm going to move everything to the left-hand side. And factor out an x on the left-hand side. Sorry, right-hand side. Directionally dyslexic. And obviously we already knew, had you graphed appropriately or accurately, that x equals 0 is 1 x value for a point of intersection, whereas well, actually 2 squared times 3 is 2 to the 6th. So I'm going to solve that. And technically when I square root, it's plus or minus 8. However, because we're only working in the first quadrant, I actually don't really need the -1. So there are our points of intersection. That is 8. And to get the y, which we will definitely need, divide by 4 is 2. So I would suggest that that would be a part I, sorry. And it's this blue highlighted region that I just highlighted that I'm rotating about the y-axis. So therefore, when I go to determine the volume of revolution, I need my integrand to be in terms of y. Because if I think about it, the outside, or the larger radii of this revolution, will be defined by my line. So therefore, I need to put y equals x on 4 in terms of x equals, so 4y, that's pretty easy, equals x. And then my inside radius, or my smaller radius, is defined by my cube root. But again, I need to solve that for x. So cube both sides, so y cubed equals x. So therefore, when I go to set up my integration, so don't forget the pi, that's definitely a typical mistake that students often make, is when they set up their volume, they forget the pi. Right? And because we're integrating in terms of y, I want to go from my smallest y, which is 0, to my largest y, which is 2. I said my outside radius, or my larger radius, when I go to rotate this blue region around the y-axis, is defined by my line. So that's 4y squared. And if I were to just simply rotate that, I actually end up with a 3-dimensional shape that is a cone that has a radius of 8 and a height of 2. But it's not a solid object, because that cube root of x is defining that shaded blue region that is being rotated. So it's somewhat hollow, although the shape shares a point at 0, 0, 0. So you can't actually say that it's hollow, and you can see all the way through it in the event that you could actually print this with a 3D printer. But I need to subtract out that inner region that is theoretically hollow. So that's where I'm subtracting off my y cube, because that's my smaller inside radius, and it's squared. And from there, it's a pretty simple integration. Meaning, as long as I apply my indices correctly, and then I've got 16y squared, and I remember to square the 4, that would be a very low level mistake to make. Multiply my powers there. Considering that I might have just differentiated in a previous question, make sure that you actually integrate by adding 1 to your power. Again, that would be a matter of just not paying attention to detail. And then evaluating this. So 16 times 2 cubed on 3 minus 2 to the 7th on 7, and evaluating that. And I would encourage final answers to be left in improper fractions. So 512 pi on 21. Not that it would necessarily be counted wrong if you converted that into a decimal. It's just a really ugly decimal. So therefore, I would encourage improper fractions and leave it.